The general formula for ketone and aldehyde is as such, and do note that the word carbonyl refers to C double bond O. And carbonyl group, like hydroxyl group, is not a functional group. It just merely describes that the compound has a carbon bonded to oxygen via a double covalent bond. So let's take a look at the various members of your aldehyde. So the first aldehyde member is none other than your methanol, then followed by your ethanol, propanol, and so on and so forth. In the case of ketone, the first member is actually your propanol, given the fact you need at least 3 carbon with a double bond O to form a ketone, followed by butanol and pentanol. In terms of aldehyde, we need to take note there is aromatic aldehyde, which is actually your benzaldehyde. Later, you will learn that benzaldehyde is more stable than your aliphatic aldehydes. So it's important to take note of that. The other compounds that's typically tested at the A level is your phenol ethanol. So the phenol group is actually the side chain. So that is actually your benzene. And your ethanol is as such. The next compound we look at is your phenyl ethanol. In terms of naming, it ought to be 2-phenyl ethanol because the benzene group is directly bonded to the second carbon. However, there's no need for you to label the number because you can never have benzene bond itself to the first carbon, because if you bond to the first carbon, then there will be no more aldehyde. Finally, in terms of naming a ketone as a side chain, you use the term oxo. So in this case, you have hexanoic acid, which is what is drawn here. So there's a C double bond O, which is actually at position number 3. Hence the word 3-oxo. So the oxo represents the O double bond to the C. If aldehyde is actually a side chain, we'll use the term formyl. So in this case, we have formyl, 2-formyl pentanoic acid. So there's carbon number 1, so there's carbon number 2. So the aldehyde group is actually bonded to carbon number 2. Let's now compare the boiling point of propanol and your propanol. In terms of the number of electrons for both molecules, they are exactly identical. And in terms of dipole moment, you'll find that in ketone, 2-methyl group bonds to the carbonyl group. So the 2-methyl group is electron releasing, rendering the carbonyl group to be more polarized, meaning to say it's more delta plus. Therefore, because of that, it actually has a higher permanent dipole. While in the case of aldehyde, you only have 1 alkyl group. So the only electron releasing alkyl group polarizes the carbonyl group. So therefore, it has a weaker permanent dipole. So therefore, because of that, with a stronger permanent dipole to permanent dipole attraction force, you will find that propanol will have a higher boiling point. Also need to note that in the case of aldehyde, none of the hydrogen that you have here are electron deficient hydrogen because the hydrogen are not bonded to oxygen. In this example here, what we want to highlight is that despite the fact that ketone and aldehyde cannot form hydrogen bonding amongst its own molecule, we need to note that it can form hydrogen bonding when it dissolves in water. So this is one example of which that the oxygen from your carbonyl group is delta minus, which is bonded to the electron deficient or protonic hydrogen in water molecules. So similarly, in the case of aldehyde, aldehyde is also capable of forming hydrogen bonds with water molecules.